In this video, we are going to learn how to implement a complete and complex JavaFX application. First of all, let's introduce the application that we are going to implement. It will be an application to manage a list of food inside a table. So each food will be assigned a category, such as vegetables, meat and fish, and so on. We can add or remove food from that table in the application, and also we can show a pie chart with the proportion of each category in the menu, in the table that we are filling with the application. This is how our application will look like. There's a table with different foods. Each food is assigned a category and a weight in grams or in ounces. So we can easily add food to the table from this form below, and we can switch to this pie chart to see the proportion of each category in the menu that we are filling in this table. Let's start by creating our JavaFX project and setting up the different elements in the initial configuration. From IntelliJ, we create a new project. We choose a JavaFX project and then fill the information in this form. Our project will be called Healthy Menu. It will be placed in the default location for IntelliJ. The default language, build system, and test framework are correct. So we can just rename the group if we want. We can just call it app. So the default package will be app.healthymenu, and the default SDK that we are going to use. So we click on next. We don't choose any additional library to be included in this project, and then we can finish with this setup. Here we have our project initialized with the source folder containing the main folder with the Java classes and the resources. We have an fxml default file with its associated controller and the main application. So the first step will be to rename all these classes to fill the requirements of our application. The default fxml file will be renamed to main fxml. So we refactor and rename this file to main. In order to do this, we need to manually rename this file in the main application. We call this main, and then we can rename this appropriately to main.fxml. Then the main controller will be main controller. Refactor, rename, main controller. And the main application will be Healthy Menu. We refactor this class to Healthy Menu. So we have our main class with our main controller associated to the main fxml file. Okay, let's go on to next step. Now we are going to define the main layout of our application. This is, we are going to place the table in the main stage above, and the form to add food to the table below this table. We move to Scene Builder tab. We can remove the default elements of this sample application. We don't need them. And then we are going to use our own controls and containers for this application. As our main container, we are going to use a split pane. In this case, a vertical split pane. So we can easily divide the main area in two sections. The table in this place above, and the form below in the second section. As you can see, there are two anchor panes as default containers for each subsection of the split pane. It's okay for us. So we can now go to controls section and place a table view in the upper section. We look for the table view in the controls list and drag this table view inside this upper section. So this anchor pane contains the table view. In order to make the table fit all the available area inside this anchor pane, we can right-click on the table and choose Fit to Parent. Then the table expands to get all the available area inside its main container, which is this anchor pane. Next, we are going to add the necessary columns to this table. We are going to need 4 columns. We already have 2 of them, so we need to add 2 more columns. We can drag and drop them inside this table view. This way, we can resize this column to our desired final size. The first column will be the food name, so it can be large. The second column will be the food category. And the last 2 columns will store the weight in grams and ounces, so they can be shorter. We can leave the appearance more or less like this, and then we can assign a different name to each column. First column will be food name. We can change it here. Second column will be food category. We can also change the name here if we want. Third column will be the weight in grams. And last column will be the weight in ounces. So this is the appearance of our table in our application. Now we are going to design the button form. We need some labels for this. One label for the food name and 2 more labels for the food category and food weight. We can duplicate this label to place a new one easily. And our third label with the food weight in grams. Next to each label, we are going to place either a text field or a combo box for the food category with a predefined set of categories. So let's start by adding some text fields for the food name and food weight. And a combo box for the food category. That's it. And finally, we need an add button to add food from this form to the table. You can place the add button here. Now we are going to wrap horizontally each set of controls in an H-box container. So we press Ctrl key and select the desired controls, these 3 controls. Then we right click on them and choose Wrap in Horizontal Box, H-box. This way, all the controls are placed inside an horizontal box. If we choose this horizontal box and go to Layout section, we can define a spacing to separate each control from the next one. We can define, for instance, a separation of 20 points. Then we do the same for second row. We choose food category and combo box. We wrap it in a horizontal box and define the spacing of 20 units. And finally, the third row with the weight. We wrap it and define a horizontal spacing. Now we can wrap all these rows in a single vertical box. We right-click on each horizontal box. By pressing Ctrl, we can choose separately these boxes when we press Ctrl, and then we wrap in a vertical box. We can also define a vertical separation, for instance, of 10 units. We have the vertical box surrounding the 3 horizontal boxes, and then we can define a vertical spacing for them. In this case, for instance, 20 units or 10 units to separate each row from the next one. Why do we wrap all these controls inside horizontal and vertical boxes? Well, in order to manage them easily if we want to resize the window. So we can choose the whole vertical box containing all the controls in the form, go to layout section and anchor the whole vertical box to left and right borders. So as we resize the window horizontally, this vertical box will adapt its size to this new container final size. If we try to run the application now, it will show too small. So we need to adapt the initial size of the table to the default size of this vertical split pane. In order to do this, we need to go to the split pane properties in the right part. In this case to the layout section, and see the preferred width and height. So we need to copy these values in the main application. In this case, a width of 600 and a height of 400 pixels. So now we can run the application again and see the initial size of every component. This is how our application looks like now. If we try to resize the width of the window, we can see that nothing happens if we extend the size, but if we shrink the size, you can see how controls also shrink. We can get to a point that the labels hide their text. So we need to tune this setup more precisely. First of all, we need to make the 3 labels get to a minimum width. Instead of using computed size, we are going to use preferred size for the 3 labels. This way, if we shrink the application, labels will not shrink beyond this preferred size. For the text fields and the combo box, we can also make them grow if we increase the width of our window. So we can choose each text field or combo box, go to the layout section. In the H grow property, we can choose always. We let it grow whenever it's possible. And in the max width, we can choose max possible value. For both text fields, we do the same. And also for the combo box. So if we try to run the application again, we can see that now it behaves correctly if we resize the main window. If we shrink the window, the labels keep their initial size, and if we increase the width of the window, then both text fields and combo box increase its size too. So we have set up the initial layout of our application. Now it's time to set up the controller. Associate the controller class to the fxml file if the connection has been lost, and add the appropriate controls to the controller class in order to access them from Java code. First step is to associate this main controller class to the fxml file. We move to the text tab, and we need to make sure that the initial or root container contains the association with the controller. In this case, this is not true because we have changed the default initial main container, so we need to specify the attribute again. fxcontroller attribute pointing to app healthy menu main controller. So now we have the association between the fxml file and the controller. We can remove these old elements from the sample of our initial project, and then we are going to add the controls from our fxml file inside this controller. To do this, we need to assign each control a name. Let's start with the table. The table itself will be called table food. So we choose the table view element, we go to the code section in this right panel and assign an fx ID. In this case, we are going to call it table food. Each one of the table columns also must have an fx ID in order to manage each column from the controller. So we are going to give a name to each column. First column will be called food name, for instance. Second column will be called food category. Third column will be called weight in grams. And last column will be called weight in ounces. From the form below, we just need to give an ID to the text fields and the combo box. So first text field will be txt food name. Combo box can be called combo category or choice category. And last text field will be txt weight. All these fx IDs have been added to the text tab, and then we need to incorporate these IDs to the main controller. To do this, remember, we can just click on each ID, click on the yellow bulb on the left, and choose create field for each one of these fields. Next step, now that we have all the controls added here, is to make all these attributes private. And then we need to go back to the fxml file and add the corresponding annotation to each attribute. Now we have all the controls associated as private attributes in our main controller. Next, we need to make this controller implement initializable interface. And then we need to override the corresponding initialize method inside this controller. Inside this method, we are going to populate combo box with default categories. So our combo box will be a string combo box, and inside this initialize method we can go to combo category, get items, and add the default categories that we are going to manage. In this case, we are going to use 4 different categories. One of them will be milk and derivatives. The other one will be meat and fish. Next one will be fruits and vegetables. And last one will be other. So we can now run the application and see how the combo box is already populated with these 4 default categories. In this next step, we are going to add some events to our application. To be more precise, we are going to add an event over the Add button so that every time we click on it, we are going to add a new food to the table. In order to manage the food in the table, we are going to add a new class called food to store all the information about a food. This food class will have food name, the food category, and the food weight in grams. From this point, we can easily generate all the constructors, getters, and setters from this menu. Code generate, we generate the constructor to assign these 3 attributes, and then we can also generate the getters and setters. For these 3 attributes as well. Well, there's one more feature that it's missing. We are talking about the weight in ounces. In this case, we are going to calculate the weight in ounces from the weight in grams. And we are going to add a new getter here to calculate the weight in ounces from this value. This is the new method, and we apply this conversion factor to transform the weight in grams into weight in ounces. Next, in our controller, we are going to manage a list of food items, of food objects. In this case, we are going to work with an observable list. This is a special type of list which implements observable pattern. What does this mean? Well, in this case, every change that we make to this list will be automatically reflected in the table. So first of all, we add a new private attribute which will be an observable list. We import this class from JavaFX collections, and then we can use this observable list to add food objects to it whenever we press the add button. So we move to the fxml file, go to scene builder, choose the add button, and we are going to define an action event over this button. Whenever we press this button, a new method called add food will be called. So we set the method name, we go to the text version, and we add this method to the controller. Inside this method, we need to make sure that every field in the form is properly filled, otherwise we will show an alert message. And then if everything is okay, we are going to add a new food object to the table. Before doing this, we need to associate each table column to a given property of food class and the table food object with the food observable list. All these things must be done inside the initialize method. Let's go with it step by step. First of all, we need to use generics with our table and columns. Our table view will contain food objects. Inside each table column, we need to specify the object that we are using, a food object, and the type of the attribute that we are showing inside this column. In this case, we are showing the name of the food, which is a string. In this second column, we are also using a string representing the category. The third column, we are using an integer for the weight in grams, and in the last column, we are using a floating point number with the weight in ounces. Second step is to associate each column with the appropriate attribute or property from food class. Food name column will be associated to a property. We can import this property value factory class. So this call food name will be associated to a property which is the name of the food. Category will be associated with the category, the weight in grams with the weight attribute, and regarding the weight in ounces, there's no attribute inside food class representing the weight in ounces. In fact, from the controller, we are not pointing to the attributes, but to the getters. So this name string points to a getter called getName. So we are going to associate this column to this getter. In the same way, category is pointing to the getter for the category. Weight is pointing to the getter of weight. And finally, weight in ounces is pointing to the getter of weight in ounces. So this text is not necessary, as the getter is called weight ounce, as we can see here. So the name in this string is exactly the same that the name of the getter without the get prefix and starting in lowercase. To see how the food is shown in the table, let's start by adding some sample food inside this initialize method, and then we will add new food from the button below. For instance, we can initialize food observable list with this predefined list of food objects. We can import this FX collection class. This is the way we create statically an observable list object from FX collection class, and then we associate the observable list to the table by adding this method. We set the items of the table from the food observable list. Let's try to run the application now. and see how these 4 food objects are shown in the table. You can see here how food name, category, weight in grams, and weight in ounces are properly shown in each column. We could tune up this last column to show only 2 fraction digits instead of 4 digits, as we can see here. But in order to do this, we need to transform the associated getter. We go to food class, and this getter, which is associated to the last column, instead of returning a floating point number, it must return a string, a formatted string. So we need to format this calculation into a string with 2 fraction digits. We can use a decimal format class or object, we can import it, to specify that the maximum fraction digits allowed in our string is 2 digits. So we format this mathematical expression, which is a floating point value, into a string with 2 fraction digits, and we return the formatted string. So in our main controller, last column is no longer showing a floating point number, but in this case it's showing a string value. This way, our last column now shows the weight in ounces with 2 fraction digits. And what about our add food event? Now we are ready to fill the code of this method. We need to distinguish if or check if every field in the form is properly filled. If not, we are going to show an alert message. If everything is okay, we are going to create a new food object with the information in the form and add it to this food observable list. And automatically, this food will be shown in the table associated to this observable list. This can be the code of this event. We firstly check that every field in the form has a value. There are no empty fields for the food name, for the weight, and for the chosen category. And if anything of this field is wrong, we are going to show an alert message saying that no field can be empty. If everything is okay, we are going to add a new food object with the corresponding values from the text fields and combo boxes into the food table. So let's see how this event works. If we try to add anything with an empty value, then this alert message is shown. But if we fill the information properly, for instance, let's add some bananas, which are fruits and vegetables, with a given weight, and then we add it to the table automatically. We can see here the bananas. However, at this point, if we close the application and start it again, we are losing all the information that we have added to the table. So we need a way to store the information, the list of food, in a text file, for instance, so that we can retrieve it every time we start the application again. Let's add a couple of methods here to read and write the information from the food list from and to a text file. But in order to ease the way of saving the information into the file, we can add a new method inside food class. It can be a toString method that just returns a string representation of this food, separating each attribute with a semicolon, name, the category, and the weight. We are going to use this method to save the information in the text file with this format and then retrieve it reading this format and transforming each line into a food object. Regarding the save method, we can do something like this. We define a save file method which receives a list of food as a parameter, and then using a printWriter object stores the information of this list into a text file called food.txt. We can use streams to easily explore the contents of the food and print each food object using toString method into the text file. Finally, we can call this method every time we add food to the table. In this case, we can call this save file and pass the food list as a parameter. So let's see how this works now. We can add some bananas as we did before. We add them here. And as soon as we add these bananas to the table, a new text file has been generated in our application. This is the text file, and here we can see the information of every food in the table with its corresponding string representation. Okay, now we need to read and load this information whenever our application is started. So we need a read file method in our main controller. This can be the appearance of the read file method. It returns a list of food from food.txt file. In this case, we are also using functional programming. We use files.lines method to get the lines of this file, food.txt, and then we map each line into a food object. Every line, which is a string, is splitted into its corresponding sections, name, category, and weight, and then we create a food instance with the parts of this line. Finally, we collect all the elements, all the food objects into a list, which is automatically returned. If something happens while reading this text file, we are going to return null. Or we can also return an empty list as well. So we can call this file, this read file method, from our initialize method, and this way we can populate this food list from the contents extracted from this text file. This way we easily replace the predefined list with the contents extracted from the text file by calling read file when we are creating the observable list. So let's see how this works. In this case, we should see our bananas from the beginning. So we can see the bananas here, and the reading process has been successful. So we have an application ready to store the information of the table in a text file and retrieve it every time we are running the application. In this last step, we are going to add here a new button to show a pie chart with the proportion of each food category in the table. So first of all, we go to our main fxml file and add a new button in this second row next to the combo box. We choose a button, we go to the second horizontal box and place it next to the combo box. This place. We can call it chart. We can also resize it. And then we need to define an event over this button so that whenever we press on this button, we need to switch to a new scene with the pie chart. So we are going to add inside this resources folder a new fxml file in the same package than the main fxml file. Let's call it chart.fxml, and then a new controller in this class package called chart controller, for instance. Regarding the chart fxml file, we are going to design it. We can remove previous content, if any. And in this case, we are going to use again a vertical split pane as our main container. In this case, the upper section needs to be bigger than the lower section. In this section, we are going to place the pie chart, and here below we are going to place just a button to come back to the main scene. So we add a pie chart from the charts section. We add a pie chart in the upper section. We can right click on it and choose fit to parent, and then we add a button to the bottom section, more or less in the middle of the section, and we call it go back, for instance. Regarding the IDs or names, we just need to give an FX ID to the pie chart in order to get it from the code. So we choose the pie chart element, we go to the code section and call it, for instance, chart. We need to associate the fxml file to its controller. As the main container has no reference to this controller, we add the fx controller attribute pointing to app.healthymenu.chartController. Then we add the chart control to the controller class, we make it private, and then finally we add the corresponding annotation. Now we have our fxml file and the corresponding controller both associated. We implement initializable interface in the controller and add the corresponding initialize method. Inside this method, we need to get the information from the table of the other controller and load it in the pie chart. How can we do this? We need to somehow get the food list from this controller and use it to populate our pie chart here. So let's go to our main controller. We are going to add a new getter here to get the food list, and we can also add here a new event over the chart button to move to the chart scene. So we go to main fxml, choose the chart button and add an action event which is going to call a go to chart view method. We add this method here to the controller, and inside this method we are going to add the necessary code to move to the other scene. This is how our method can look like. We are using fxml loader to load the corresponding fxml components. We use healthy menu class to locate the resources associated. Keep in mind that healthy menu and any other class is located in the same package than these resources. So we can get the resources from this same package even if they are placed in different folders. This is the source folder and this is the resource folder, but both packages are the same, so we can get a resource from this section if we are using the code from this other section. Then we load the components, we create the scene with these components, and we get to current state and change the default scene to this new scene. We can do the same on the other side. We go to the chart fxml view, click on the go back button and define a go back method to go back to the main scene. We include this method in the chart controller and define a code which is more or less the same than previous code but pointing to the other fxml file. This is the code that we need to go back to the main fxml file, and you can see that the rest of lines are more or less the same that we used here in our main controller. If we try the application, we can see that as soon as we click on the chart button, we move to the chart scene or view, and if we click on the go back button, we go back to this main scene. So there's one thing missing. We need to implement the code of this initialize method to get the food from the main controller. We are going to use this method and then use this list to populate the chart that we are going to use in this new scene. First of all, we need to get to the other controller. So we use fxml loader to get the contents of the main fxml file, and from these contents we are going to get the associated controller, which is a main controller object. Now that we have this main controller, we can easily get the food list of this controller. So in this variable, we are going to finally get the current food list from the main controller. Now that we have the food list, we can use it to populate this pie chart. First of all, we clear the previous data on the chart, if any, and then we are going to map the results of the food list into the pie chart. As you can see, we are using a stream over the food list so that we are grouping the items in this list according to the category. And then we are going to sum up the weights of the food grouped by category. Then, now that we have a map with each category and the total sum of their weights of this category, we add each item of this map into the pie chart, associated each category with the total sum of the weights of this category. This way, we show the proportion of the total weight of each category in the table that we are filling. We can see how this works. In our case, we have 2 entries for fruits and vegetables with a total weight of 350 grams, 2 entries for meat and fish with a total weight of 600 grams, and a single entry for milk derivative with 250 grams. So if we need to see the proportion of each category in this chart, we can see that meat and fish consist in the half of the weight shown in the table. We have a total weight of 1,200 grams, and from this total weight, these 600 grams correspond to meat and fish. So we have implemented a complete application to show some of the most important features that we can use from JavaFX, such as dealing with tables, using forms to populate tables, and also showing different scenes in the same application. I hope this video can be helpful for you in order to implement your own JavaFX application in the future.